Welcome to the virtual tutor series on core mathematics for senior high schools. In this lesson, we cover expansion of algebraic expressions. For a better appreciation of this lesson, I highly recommend that you first watch our previous video lessons on introduction of algebraic expressions, as well as operation on algebraic expressions, if you haven't done so yet. Having said that, let's move straight to today's lesson, expansion of algebraic expressions. We will learn how to expand the following types of algebraic expressions. Number one is an expression that contains a factor and a quotient. Number two is an expression consisting of the multiplication of two binomials. 3. We will also look at the expansion of a perfect square. And 4. We will look at the expansion of the difference of two squares. Now, let's look at how each expression type can be expanded. Type 1. A factor and a quotient. For instance, given the expression a into bracket b plus c, bracket closed, the term outside the bracket, that is a, is the factor, and the terms inside the bracket, that is b plus c, is known as a quotient. To expand the expression is to remove the bracket. How do we do this? Well, we do this by applying the distributive law. In other words, we multiply the factor by each of the terms inside the bracket before adding or subtracting like terms, if any. Now, back to the expression a into bracket b plus c, bracket closed. We distribute a over b and c. So we have a times b plus a times c. A times b is ab and a times c is ac. So we have ab plus ac. For a practical understanding, let's consider the following examples. Expand and simplify the following expressions. Solution. Example 1 is 2 into bracket 3a plus 2b, bracket closed. The first step is to distribute the factor over the terms within the bracket. So we have 2 times 3a plus 2 times 2b. 2 times 3a is 6a and 2 times 2b is 4b. Since there are no like terms, we leave it as it is. Example 2. 3x into bracket 4x minus 5y plus 2z, bracket closed. Step 1. We multiply 3x by each of the terms in the bracket. So we have 3x times 4x minus 3x times 5y plus 3x times 2z. 3x times 4x is 12x squared. Negative 3x times 5y is minus 15y. and 3x times 2z is 6xz. And again, since there are no like terms, we end it here. Example 3. 7 into bracket y plus 1 bracket close minus 2 into bracket 2y plus 3 bracket close. Step 1. Let's distribute 7 over y and 1 and negative 2 over 2y and 3. So for the first part, we have 7 times y and 7 times 1. And for the second part, we have negative 2 times 2y and negative 2 times 3. 7 times y is 7y. 7 times 1 is 7. Negative 2 times 2y is negative 4y. And negative 2 times 3 is negative 6. Since there are common terms, we need to move on to the second step by adding or subtracting the common terms. So we have 7y minus 4y to be 3y and 7 minus 6 to be 1. Awesome. Shall we now move to the expansion type 2, which is the multiplication of two binomials? As the name suggests, a binomial is an expression that contains two terms separated by an addition sign or a subtraction sign. For example, the expression into bracket a plus b bracket close times into bracket c plus d bracket closed is a product of two binomials. A plus b is a binomial expression with the terms a and b separated by a plus. C plus d is also a binomial expression with the terms c and d separated by a plus. We can expand the product of two binomials by multiplying each term in one bracket by each term in the other bracket before adding or subtracting like terms, if any. So the expression a plus b times c plus d can be expanded by multiplying or distributing a over c and d and distributing b over c and d. That is a into bracket c plus d bracket closed plus b into bracket c plus d bracket closed. A times c is ac and a times d is ad. So the first bit of the expression expands into ac plus ad. Again, b times c is bc and b times d is bd. So the second bit of the expression expands into bc plus bd. clear understanding, let's consider the following examples. Expand and simplify the following. Solution. Example 1. Into bracket 3x minus 2y bracket closed times into bracket 3x plus 2y bracket closed. The first step is to multiply each of the terms in the first bracket by each of the terms in the second bracket. So we have 3x into bracket 3x plus 2y bracket closed minus 2y into bracket 3x plus 2y bracket closed. Now, let's remove the first bracket and second bracket. So we have 3x times 3x to be 9x squared and 3x times 2y to be 6xy. Again, negative 2y times 3x is negative 6xy and negative 2y times 2y is negative 4y squared. Now, the second step is to add or subtract like terms. So 6xy gets rid of negative 6xy, and the final expression now becomes 9x squared minus 4y squared. Example 2. Into bracket 2x plus y bracket close times into bracket x minus 2y bracket close. Step 1. Let's distribute 2x and y over x minus 2y. This gives us 2x into bracket x minus 2y bracket close plus y into bracket x minus 2y bracket closed. 2x times x is 2x squared. 2x times negative 2y is negative 4xy. Y times x is xy. And finally, y times negative 2y is negative 2y squared. Step 2. Let's add or subtract the like terms. So we have 2s squared and negative 4xy plus xy gives us negative 3xy, and then minus 2y squared. Example 3. 3 into bracket 3y minus 1 bracket closed times into bracket 6y minus 5 bracket closed. This expression consists of both the type 1 and type 2. There is a factor and a quotient, as well as the product of two binomials. It is therefore advisable to expand the product of two binomials first, before multiplying the result by the factor. So we have the factor 3, bracket opens, 3y times 6y is 18y squared. (3y times negative 5 is minus 15y. Negative 1 times 6y is minus 6y. And negative 1 times negative 5 is 5. Bracket closed. Grouping like terms, we have 3 bracket opens 18y squared and negative 15y minus 6y gives us negative 21y, and then plus 5, bracket closed. At this point, we can distribute the factor over the terms in the bracket. So we have 3 times 18y squared to be 54y squared. 3 times negative 21y to be negative 63y. And 3 times 5 to be 15. Well done. Here is where we end today's lesson. In our next lesson, we will take a look at the other two expansion types, which include perfect square and difference of two squares. If you found our educational videos helpful, kindly join the Virtual Tutor Series family by subscribing to our YouTube channel. This way, you can receive notification on future videos. Thank you for watching and see you in our next video lessons.